I hope you enjoyed getting to play around with Remix a little bit. It really is a fantastic tool, and I expect you'll use it quite a bit, not only in this course, but in your own projects as well. I now want to do a little bit of focus and talk about some of the behind the scenes stuff that's occurring here. First, I want to talk about exactly what happened when we selected our inbox contract right here, typed in some entry argument, and then clicked the create button. So in other words, what really happens on the Ethereum network when we try to deploy or create an instance of a contract. The first thing I want to do is remind you about one topic that we spoke about earlier in this course. If you recall, earlier in the course, we created an account with MetaMask, and then we used this xbte test faucet to send some ether to that account. So that was a transaction that sent money from my account over to yours. We spoke about the transaction object that was used to represent that movement of money. And we also spoke about all the different properties that that transaction object had. When we create a new contract, a very similar process occurs. So creating a contract is very similar to the transfer of money between two different parties. There's just some very small differences, and we'll talk about exactly what those are right now. So just as before, whenever we want to send money from one person to another, we are going to create, or we're going to take our account. It is going to author a new transaction. This transaction right here will have a purpose of trying to create a new contract. And we're going to send that from our account over to some specific network. And that's what makes sure that some specific network, like in this case xbte, attempts to actually create the contract. Now let's talk about the actual transaction object that's being used here to create the contract. So this is an external account to create a contract transaction. Let's put that word on there just to make sure it's clear. This transaction looks very similar to the one we were looking at previously that was attempting to move money between different accounts, but it has the inclusion of one additional field. First, you'll notice that we still have this nonce thing. So nonce is recording how many times the sender has sent a transaction. In this case, the sender is the person who is trying to create the contract. In the context of Remix, some of these like sender things might seem a little bit weird, right? Because it doesn't seem like we're really interacting with MetaMask at all. But remember, in Remix, we had this selection right here for an account. So when we are trying to create any new contract right here, this selected account is being used as the sender for this contract creation transaction. Next, we have the to field. You'll recall that previously, the to field reflected the address of the person that we were trying to send money to. The big difference between a money sending transaction and a contract creation transaction is that this to field right here is left as blank. So if we send a transaction into the network and leave to blank, that means that we are going to attempt to create a new contract. And in fact, we could even recall that we use the Web3 library to interact with the Ethereum network directly, programmatically. We can actually send in a transaction and just leave the to field blank, and the Ethereum network will automatically assume that we are trying to create a contract. And it will create a completely empty contract if we don't actually include any code with it. So just the mere fact that we leave to blank right here results in a contract being created. The other property that we need to be aware of that's only present on these contract creation transactions is the data property. This is the actual compiled bytecode of the contract. So this is where the code that comes out of the Solidity compiler is sent in and stored on the network. Specifically, the code gets stored in the account that is created that represents our actual contract. That's actually an important thing to be aware of. Whenever you write one of these contracts and deploy it to a network, all the code, or at least the raw bytecode, is available for everyone else in the world to read. So there's really no concept of inherent security of the code we write. So usually whenever we write a contract, we don't try to put some secret sauce in there or some secret business logic. No, everything that goes in there really is exposed to the world. Now, the last thing to remember is that this contract will still be signed with these V, R, and S properties, which are derived from the sender's private key and can be used to derive their public key. So this is where it says essentially, this is the person who is trying to create this contract. Now, a contract creation transaction can still have a value assigned to it. If you assign value to a transaction that's being that's being used to create a contract, then the contract that is created will have some initial value or some initial balance of ether assigned to it. So in one step, we can both create a contract and send it some initial amount of money that it can play around with to do whatever it is our contract is trying to achieve. All right, so that's a little bit about the contract creation process. Now I want to take a break, and in the next video, we're going to talk a little bit more about some really interesting facets of the difference between the two different types of functions that we were working with here, both the type that seemed to return some data or kind of get some data for us, and the type that seemed to modify some of the data inside the contract. So let's take a quick break and then talk about these functions.